In this video, we're going to look at L'Hopital's, that's how we say that, L'Hopital's rule, in the 0 over 0 case. So what L'Hopital's rule is it's a limit theorem. And the idea is that if we had something like, I'll keep it easy. If we had something like that, the limit as x approaches 1 of x squared minus 1 over x minus 1. If I plug in 1 into both, I get 0 over 0. So back in the beginning of the semester, we would do some algebra to reduce this and then plug this in. Well, what L'Hopital figured out is that what you can actually do is, assuming both are so you're basically looking at the top is what's called f in our formula, and the bottom, which is called g in our formula. And as long as these two, if I look at x squared minus 1 separately and x minus 1 separately, as long as they are continuous and differentiable, you can do the following. So what L'Hopital says is it says, okay, take the derivative of just the top. So the derivative of just the top is 2x. Okay, take the derivative of just the bottom. The derivative of the bottom is just 1. So what L'Hopital figured out is that wherever the original function was going to, assuming it had a limit, if you take the derivative of each piece separately and then plug in the limit, so now we're going to plug in x as 1, we get the same answer I would have originally gotten. So again, if we remember back in the beginnings of the semester, we would have had to factor this originally and then plug in 1. So notice we are getting the correct answer, we're just getting it a different way. All right, so how do you use this rule? It's pretty easy. If you have the form 0 over 0, and assuming these derivatives exist, then all you do is take the derivative of the top, the derivative of the bottom, and then plug it in. If after you plug it in, you get 0 over 0 again, you do it again. Okay, so let me pause this for just a second and we'll do some more examples. All right, in this example, again, I would want to put in this number into my fraction here. If I plug in x is 0, I get the square root of 4 is 2, minus 2 is 0. And then when I plug in 0, I get 0. So we're going to use L'Hopital's rule. Now, just as a little kind of note to anybody looking at your work, what I typically do is to let people know I'm using L'Hopital's rule, I do a L''H, because otherwise it looks like a miracle occurred. Okay, so what I'm going to do is I write this saying, hey, I'm going to use L'Hopital's rule, and how it works is I'm going to take the derivative of the top. So remember, this is x plus 4 to the 1/2. So this would be 1/2 x plus 4 to the negative 1/2 times 1, and the derivative of 2 is just 0. Okay, and then the derivative of x is just 1. So this isn't quotient rule, guys. This is just taking the derivative of the top separately and the derivative of the bottom separately. All right, now we're going to plug in x is 0. So if I plug in x is 0, I'm going to get 1/2 times 1 over the square root of 4. That's a half. A half times a half is 1/4. Cool. All right, let's do one more example. What about trig? Can I squeeze it in here? I think I can. All right, so let's say I had the limit as x approaches 0 of sine of 5x over x. So in order to use L'Hopital's rule, I need to plug in and make sure I get 0 over 0. So I get the sine of 0 is 0 over 0 is 0. Awesome. Okay, I'm going to use L'Hopital's rule. So I'm going to write an LH so that anybody looking at my work knows what I did. Okay, let's take the derivative of sine of 5x. That's going to be 5 cosine 5x by chain rule. Okay, and the derivative of x is 1. All right, now let's plug in 0. When I plug in 0, I'm going to get 5 cosine of 0 Cosine of 0 is 1 over 1. This whole thing will have the answer 5. That is L'Hopital's rule in the indeterminate form of 0 over 0.